guys, today we are going to do 2-7 absolute value functions and graphs, so you will be able to graph absolute value functions. The big idea, just as the absolute value of x is the distance from 0, the absolute value of f of x, or the absolute value of a function of x, gives the distance to the line y equals 0 for each value of x. So the simplest example of an absolute value function is that f of x is equal to the absolute value of x. The graph of the absolute value of a linear function in two variables is a V-shaped and symmetric about the vertical line called the axis of symmetry. Such a graph has either a single maximum midpoint or a single minimum point of the that's called the vertex. So, if we look at the graph of an absolute value, this is our vertex, that point. The line that goes through that point is called our axis of symmetry. And, as you can see, the V is reflected on both sides of the axis of symmetry. So, what is the graph of the absolute value function y is equal to the absolute value of x minus 4? In order to graph that, we can make a set of ordered pairs, so let's make a table -3, -2, -1, 0, -2, 3. And plug those values in, so the absolute value of -3 is 3, minus 4 is -1. The absolute value of -2 is 2, minus 4 is -2. The absolute value of -1 is 1, minus 4, -3. And go ahead and continue filling out those. But when you're done filling out this table, go ahead and graph each of these sets of ordered pairs. So we have -3, -1, and then go ahead and collect my points. And this looks just like my absolute value graph in the last function, but we only started down 4, which makes sense to us because our equation is y is equal to the absolute value of x minus 4. This minus 4 is our d, which is a vertical shift down. These are all of our transformations that can be done to absolute value that we already know, so go ahead and review those. You don't need to write them all down again now. And we can also combine our transformations, so we've seen problems like this in class. We need to identify what our transformations are. We have 2 and we have 3. 2 is C, 3 is D. If 2 is positive, that means I'm going to the left 2, and down, I'm sorry. When D is positive, we have up 3. So I'm going to the left 2 and up 3, wherever we find that vertex. This is to the left 2, this one is to the right, this one is to the right, this one is to the left 2, and up 3 is our vertex. So D is the graph that represents y is equal to the absolute value of x plus 2 plus 3. We also have vertical stretches and compressions. Here we have y is equal to 1/2 times the absolute value of x. So, we're going to use this 1/2, which we know is a vertical shrink, to graph our absolute value. So this time we'll do -2, -1, 0, 1, and 2. 1/2 times the absolute value of -2. The absolute value of -2 is 2. 2 times 1/2 is 1. 1 half the absolute value of -1 is 1 half 0 is 0. And we know that it's going to reflect here. So the absolute value of 1 is 1 times 1 half is 1 half. The absolute value of 2 is 2 times 1 half is 1. And you can see now that we vertically shrunk because we took our y values and we shrunk them down. So combinations of transformations, we can have A, B, C, and D for our absolute value, just the same as we were having it in class. The easiest way to graph absolute value is to find the vertex, and the vertex is located at the opposite of C, D. So that will be the first thing that we need to do is find our vertex. And the axis of symmetry goes straight through our vertex. So it's a vertical line, so its x is equal to the opposite of C. So with our graphing, we need to find the vertex and the axis of symmetry to this absolute value function. I'm going to look for C and D. So C is -2, which means my vertex is going to be at 2. And D is 4, so it's going to move up 4, so my vertex is 2, 4. Then to state my axis of symmetry, I'm going to say x is equal to 2, because it's going straight through my x coordinate. How is this transformed from an inherent function? Well, we have A because we're on the outside, C because we're on the inside, and D because we're on the outside. So if A is greater than 1, we vertically stretch. By 3, C is negative, so I'm moving to the right. 2, and D is positive, so I'm moving up 4. That's it.